Okay, today we will discuss about one example of frequency modulation or phase modulation, whatever you can tell, and we will solve a problem for better understanding of frequency or phase deviation or how to estimate the bandwidth of an angle modulated signal. Let's consider an angle modulated signal with carrier frequency omega c is 2 pi into 10 to the power 5 radian is described by this equation xt 10 cos omega c t plus 5 sin 3000 t plus 10 sin 2000 pi t. The question asked to calculate the power of the carrier signal, the frequency deviation, phase deviation, deviation factor, and estimated bandwidth. The first question comes to the mind, whether it is frequency modulated or phase modulated. I think students should not go into this trap of what type of modulated signal it is. Rather, consider it as an angle modulated signal. Okay, so if we consider it as a general angle modulated signal, so at first I will calculate the power of the carrier. Naturally, the carrier was 10 cos omega c t, we can consider, and power is AC square by 2, so naturally it gives 50 watt. And if we see the expression, you see this total part omega ct plus this sign, this we call it as angle. Okay, this we call it as angle. And deviation from this omega ct, that is this part, we call it as phase. Okay, so what is the instantaneous angle? Instantaneous angle is this one, and among this phase is this part. So what is the phase deviation? We call phase deviation when the deviation of the phase is maximum. When it will be? When these two signal, sinusoidal signal, will add in phase. Then what will be the value? The value of the deviation will be 5 plus 10. That means 15 radian will be the phase deviation. And we have learned from frequency modulation and phase modulation that if we take the derivative of instantaneous angle, we will get instantaneous frequency. So if we take the derivative of this, we will get omega c plus 15,000 cos 3000 t plus 20,000 pi cos 2000 pi t. This is our d phi dt, that means instantaneous derivative of instantaneous angle or instantaneous frequency d phi dt is this one. In the similar way, like phase deviation, frequency deviation is also defined as the deviation when the deviation is maximum. This will happen when this cos 2 signals will be in add in phase, and then the frequency deviation from omega c will be 15,000 plus 20,000 pi. That will be the frequency deviation, maximum frequency deviation or simple frequency deviation. So this we get as del of omega, frequency deviation. And what is omega m? Omega m is the frequency, highest frequency of the modulating signal. Now if we go to the expression of the given problem, we see this is our part where we have the message signal or its integration, whatever may be. The frequency is omega t, that is 3000, another omega is 2000 pi, and we define frequency of a signal as the highest frequency part, the component, and highest frequency obviously 2000 pi is greater than 3000, therefore omega m is 2000 pi. Substituting this in the expression of beta, that is deviation factor or frequency deviation factor, as del omega by omega m, we are getting this expression. And bandwidth, as we know, bandwidth can be defined as twice into del f plus fm. Del f we have obtained from here, and fm we have just derived, or rather not derived, we have just calculated. If we divide it by 2 pi, we will get fm, and The bandwidth obtained is 26,774.65 Hz. Thank you.